Thanks very much, and thanks for coming along, everyone. Oh, gorgeous Marlborough Day, isn't it? Fantastic. It's lovely to be back here. My name's Mike White. I'm a writer for North and South magazine, but grew up here in Marlborough. That's the reason why I get invited back to be involved with this wonderful book fest. Thanks ever so to the organisers of this book festival. It's a fantastic little event. Thanks to Spy Valley for hosting us again. And thank you very much again to everyone here for coming along and supporting it, because you're the people that make this festival as successful as it is. And you are the lucky audience that get to be present for the very first international guest that we've had at the Marlborough Book Festival. Now it's fourth year. So today we're welcoming John Pickrell from, John grew up in England, near London, spent a bit of time in the States, and then went to start a new life in Australia, and for the last 10 years he's been based in Sydney. John's an award-winning journalist, and he's written for a number of top magazines and publications around the world. He was the editor of Australian Geographic magazine. He's written two fabulous books that we'll talk about today: Flying Dinosaurs and Weird Dinosaurs. I want to write a book with a cooler title as that. Weird Dinosaurs. It's brilliant. John's got a master's in taxonomy and biodiversity from the Natural History Museum in London. He's a journalist, a science writer, and a dinosaur expert. And that's obviously what we're here to talk about today. And John, welcome to Marlborough, and it's great to have you here to talk to us today. So can everyone just welcome John? Thanks. John, take me back to your first kind of association or interest in dinosaurs. Standing there as a young kid in London's Natural History Museum, staring up at this 32-metre fossil Diplodocus, the Diplodocus. Can you take us back there, and what was it about that fascinated you, like a lot of kids, I imagine?
I think loads of kids in the UK, probably their first memories of dinosaurs are standing at the Natural History Museum and looking up at this huge sauropod skeleton, which, you know, it had been there since 1905 or something, and it was there until 2015, but sadly it's been removed now. But yeah, I really remember as a small child being quite enchanted by this huge skeleton.
Enchanted and scared at all, you know, dinosaurs?
I don't think I was scared. I think I just was completely fascinated by these really strange animals that were unlike anything that we have in the world today.
And what were you doing there? Were you just allowed to roam, you know, your parents say, well, you go, just roam around the museum? Because I understand your parents were kind of very encouraging about, your interest in this area.
Yeah, I think like my mum particularly really had a lot of interest in wildlife and natural history, and she really kind of inspired me to be very interested in animals and nature and fossils, and it kind of led to this interest in dinosaurs. But I think really my big interest in dinosaurs and fossils particularly came when I did this master's course at the Natural History Museum. So the Natural History Museum in London have about 80 million specimens there. It's just completely incredible. You can see about 500,000 of those on display, but behind the front of the museum it's just like an enormous university campus that goes on and on with buildings and towers. And when I was doing the master's course, really we just sort of had free reign behind the scenes to wander around all of the museum's collections and, you know, open cupboards and pull drawers out. And so I'd sort of had a really great interest in fossils and dinosaurs since then, but ultimately I decided to become a science journalist. But I continued to write stories about dinosaurs over the years, and from 1996 through to when I started working on the first book, which was about 2012, there had just been this incredible sequence of discoveries of feathered dinosaurs in China, and I had written about those dinosaurs, some stories for New Scientist, other stories for National Geographic, and I sort of kept this great interest in dinosaurs, and that's really what built up to writing the book about it.
Yeah. We'll just think about that. We'll go right through the dinosaur age to the end of dinosaurs, and we're going to work back. But I mean, a lot of people will know a bit about dinosaurs and how 66 million years ago they went extinct essentially because of an asteroid, when an asteroid hit just off the Mexican coast. Can you explain a bit about that extinction, because what I want to get to is how not all the dinosaurs actually died. And you can tell us about that. But just help us out. The asteroid comes, whacks into Earth. It's not like it just physically smashes all the dinosaurs. How is it that the dinosaurs die out when the asteroid hits?
Yeah, I mean, so when this, we're still not sure whether it was a comet or an asteroid. It was something that was probably about 10 or 15 kilometers in diameter, and when it hit the Earth, it hit with such force that it would have like plunged right through the surface of the Earth, deep into the magma. It would have thrown material right up to the upper reaches of the atmosphere. There would have been global wildfires right across the planet. Possibly, it struck in North America, but possibly there would have been wildfires even in the parts of Gondwana like Australia and New Zealand, because there would have been burning embers falling from the atmosphere. The atmosphere was clogged with soot, and it would have been like a nuclear winter, really, which certainly went on for months, but it may even have gone for years after the event. And this is why the vast majority of species on Earth did not survive. Perhaps about kind of 80-90% of species became extinct across the whole planet at this time, and in fact no animals at all larger than about 25 kilograms in size would have made it through. So none of the larger dinosaurs were able to make it. But other smaller crocodiles, reptiles, mammals, and the small feathered dinosaurs that we know of as birds were able to survive. They were able to make it through. And experts are still not entirely sure why some animals were able to make it through when others weren't. And it's still a very, very active area of debate around birds at the moment. And there are some ideas that, birds were able to fly, they have beaks, so they may have been able to forage over very large areas, and with beaks you're able to crack open seeds. So it might have been that there were very limited food resources for years. Some birds were better able to survive than the larger dinosaurs.
First of all, we better clear up this for people, because when they look out and see sparrows flitting around the vineyard, they don't think dinosaurs, John, do they? So
no, they
can you
really
explain that birds that we see around are the descendants, or are actually dinosaurs?
But birds are not just the descendants of dinosaurs. Birds are dinosaurs, and in fact they are carnivorous dinosaurs. A sparrow is much more closely related to a Tyrannosaurus rex than a Tyrannosaurus rex is to a sauropod dinosaur or some of the other herbivorous dinosaurs. So birds evolved from small feathered carnivorous dinosaurs, animals perhaps a bit like Velociraptor. And they're definitely part of that family in the same way that humans and chimps are both primates. Birds and carnivorous dinosaurs are both part of this carnivorous dinosaur family.
And we didn't really understand this, did we, till about the middle of the 19th century, with the discovery in a German quarry of Archaeopteryx. And can you tell us a bit about that story? Yeah,
so Archaeopteryx was found in about 1850. Archaeopteryx was called the first bird, and it was an animal from about 150 million years ago in the Jurassic. It was found in these incredible deposits in Bavaria in Germany, and the fossil was remarkable. It was covered in these great fans of feathers around the forearms. It was clearly a bird, but it also had jaws with teeth, and it had a long bony tail, as well, which are reptilian traits. So really there was quite a bit of debate at this time about whether it was a dinosaur or whether it was a bird, but that idea kind of got forgotten, and this link between dinosaurs and birds was sort of not explored in any great detail again until the 1960s, really. And in the 1960s, there was a kind of dinosaur called Deinonychus that was found in North America. Deinonychus is an animal very similar to Velociraptor, and it was an American researcher at Yale University, a guy called John Ostrom, who realized there were a lot of similarities in the skeleton to birds and to Archaeopteryx, and really he raised this idea again that dinosaurs probably were not these kind of dim-witted, slow-moving, lumbering reptiles. They were actually animals that were much more like birds. They would have had fast metabolisms. They probably would have been warm-blooded. They may have been social animals. So starting in the 1960s through the 70s, there was this idea kind of called the dinosaur renaissance, which reimagined dinosaurs to be animals much more like living birds. But really it wasn't until 1996 that the first feathered specimen of a dinosaur, an animal called Sinosauropteryx, was discovered in China, that just proved beyond doubt that birds were dinosaurs, were animals that had evolved from the dinosaurs.
And this whole idea of dinosaurs having feathers, takes a bit of getting your head round, given what we've traditionally thought about. Not all dinosaurs had feathers, but a lot of them had some kind of, I think the word's enflufflement.
Yeah,
that's a scientific term for real.
It's not really a scientific term, but yeah,
it's a lovely. It's one of the nicer words out there. Yeah.
Well, actually, there's dino fuzz, and that is a scientific term. So, dino fuzz kind of means like chick-like fluffy down, and a lot of dinosaurs would have been covered with this kind of more like fur or hair-like covering, but it is actually a kind of feather, in the same way that fuzzy down on a chick is actually a kind of feather. So, but we now know that the majority of carnivorous dinosaurs were animals that were covered in feathers, and carnivorous dinosaurs all over the world were animals that were covered in feathers. And there's evidence for feathers in a whole number of different herbivorous dinosaurs, but we also have a lot of scaly skin impressions for sauropods and duck-billed dinosaurs and armored ankylosaurs. So we know that a lot of these animals probably weren't covered in feathers, but it might be that some of the kind of earliest, most primitive dinosaurs were animals that were covered in feathers, and then they evolved kind of into the carnivorous dinosaurs and birds, and some of these herbivorous groups of dinosaurs and feathers were lost in some of these later groups.
Okay, dumb question, and there's going to be a few of those from me. But what was the point of feathers for dinosaurs? Was it insulation? Was it as part of a mating ritual, or what was it?
Yeah, I mean, you made a good point in that we think of feathers as being completely entwined with this idea of flight. So it's quite sort of difficult to get your head around that feathers might have had another purpose entirely. But before, birds evolved perhaps 150 million years ago during the Jurassic period, maybe earlier than that. But feathers were around for at least 100 million years before that point. And for much of that time, feathers were not used for flight at all. So the initial purpose of feathers really wasn't flight. I mean, it's thought that the initial purpose of feathers was for insulation. So it would have been for dinosaurs that were covered in a kind of fuzzy, fluffy covering, which raises another interesting point, because there's no point having insulation unless you're a warm-blooded animal. If you're a cold-blooded animal, you're covered in fur or feathers, then it's actually going to be more difficult to get the heat of the sun and heat you up. So it really suggests that all carnivorous dinosaurs were warm-blooded animals as well. But so we think the earliest dinosaurs to have feathers used them for insulation, but over time they came to be used for display as well. So from China, there have now been about 50 species of feathered dinosaurs discovered, in incredible deposits where you can see the kind of feathers all across the body, and the detailed shape of the feathers and the way the feathers were arranged around the arms. And you can see that these feathers couldn't have been used for flight either. They were feathers that were more like the kind of feathers that we're familiar with today. They're the kind that had the kind of long vein in the centre, and the feather kind of fluffy bits of the feathers coming off the sides. But in modern birds, flight feathers are asymmetrical. The arrangement around the vein is asymmetrical, and a lot of these dinosaurs that had these large feathers, they didn't have that shape and arrangement at all, and the dinosaurs were animals that were too big that would have been able to fly. So we think probably they were used for display purposes, a bit like how feathers are used on a turkey or a peacock today. So they may have been brightly coloured animals that had large fans of feathers that used them for mating dances and other purposes. And it was only much later in evolution that feathers started to be used for flight. And some of the earliest dinosaurs that we can see that flew were actually four-winged dinosaurs, so that they had these great fans of flight feathers on their hind limbs as well as their forelimbs, and even around their tails too. And there were all these kind of interesting experiments going on with flight around the time that birds first evolved.
You mentioned that about 50 species of feathered dinosaur have been found in China. I mean, this is something that is really important, that we are pretty much in a golden age of dinosaur discovery at the moment. Is that fair to say?
Oh, absolutely. There's just kind of explosion of discovery at the moment like we've never seen before. So around 50% of the dinosaur species that we know of in total have been discovered in the last 10 years. About 75% of all dinosaur species have been discovered since 1990. So in 1990 there were only around 285, 300 well-established species. Now we're at something like 1,200 species of dinosaurs. So, if you think that Jurassic Park came out in 1993, the vast majority of what we know about dinosaurs we've learnt since Jurassic Park came out.
How close was Jurassic Park, actually? Did they do a reasonably good job, or were they wildly off the mark?
For the time, in 1993, it was absolutely bang up to date, based on the best science, and they were incredible reconstructions, and they really did quite an amazing job. Because that was in 1993. It wasn't until 1996 that we discovered the first feathered dinosaur. But unfortunately, with Jurassic World, which came out in 2015, they haven't updated the dinosaurs based on any of the new information at all, which I think has been a little bit unfortunate.
Where are the hotspots then that we're finding all these new fossils and making all these discoveries?
Yeah, a heap of stuff is coming from China. So, like I said, there have been about 50 feathered dinosaurs discovered since 1996, but in total there have probably been about 200 dinosaurs that have come out of China since the early 1990s. But then also Argentina, particularly Patagonia in South America, finding huge numbers of dinosaurs there. And the kind of dinosaurs we've been finding in China have been biased towards these feathery carnivorous dinosaurs of all different sorts. What we're finding a great deal of in South America are enormous sauropod dinosaurs, the biggest dinosaurs that ever existed. So there've been a whole series of them. It's probably 2 or 3 new sauropods a year are coming out of Argentina at the moment.
Look, we'll just deal with that massive one in the Titanosaur that was discovered in Patagonia. 70 tonnes, about the size of 2 jetty liners. It was about 10 times the size of T-Rex. It could easily look into a 7th floor window. And it was so big that it had to sleep standing up for fear it might not be able to get up if it lay down. But, okay, so it's 70 tonnes, and it's got a brain about the size of a tennis ball. Is that right?
Something like that, yeah. And it actually, sauropod dinosaurs actually had another kind of cluster of nerves further down their back towards their tail, because it would have taken several seconds for a nerve impulse to pass from the head to further down the body. Yeah.
Do we know how and why it got so big?
Yeah, sauropod dinosaurs, again, this is another very active area of research at the moment, because it's a real puzzle, because there are no animals that come anywhere near that size in the world today. And in fact, the largest ever mammals only reached kind of about 10% of that size. So, there are a few different theories. There is one idea that birds and dinosaurs had incredibly efficient metabolisms. So birds have a very unusual lung setup in that they have air sacs that pass from their lungs throughout their bodies, throughout all of their bones, into their limbs. And it means they're able to get oxygen much more efficiently throughout their systems than us, where we have this lung where we have to sort of draw air into a sac and then pump it out, and the blood carries it round to the rest of the body. So it could be that sauropod dinosaurs also had a very complex system of lung sacs that kind of meant they had oxygen throughout their whole bodies, and that's not a system that mammals have. So there might be a kind of ceiling for the maximum size a mammal can get to because of its metabolism. But in terms of why they grew this large, one idea is that it was kind of a feedback loop with carnivorous dinosaurs. As the carnivorous dinosaurs got bigger, herbivorous dinosaurs had to get bigger as defense against them. There's also an idea that they were eating ferns and other foods that were sort of of very low nutritional value. So the way that you can digest these foods is by having these sort of huge fermentation chamber guts. In a similar way that a cow has several stomachs today, and the way that cows digest grass is through microbes in their intestines. But the longer your gut gets, the more efficient you get at processing this material. So again, that could have been a bit of a feedback loop in that they were able to more efficiently get nutrients out of their food as they grew bigger, but then it meant that they needed more and more food as well. So
I think I just struggle to think I'm on the 7th floor of a hotel or something and a dinosaur is staring through the window. That is truly massive. But honestly, some of the species that we're discovering now are weirder than anything movie producers have come up with in the past. Would that be fair to say? They are truly bizarre.
Can I just make a point actually about what you were saying? So that huge dinosaur would have been 40 meters in length, weighing up to about 70 tons. So the smallest dinosaur is an animal that's alive today. It's the bee hummingbird from Cuba. So this bird weighs about 3 grams. It's literally the size of a bee. So it just sort of shows this incredible plasticity in the sort of body shapes and forms of dinosaurs that they, I can't remember the figure now, but I did a calculation in my book of like the many millions of times the weight of this bee hummingbird that these giant sauropods were. So it's interesting that dinosaurs had this amazing diversity of body shapes and forms, and it comes on to what you were just saying, that there were some incredibly weird new kinds of dinosaurs that we're discovering today. So when people think of dinosaurs, really they think of animals like Triceratops, Stegosaurus, Brachiosaurus, Diplodocus, T-Rex, but all of these dinosaurs are animals that were discovered in North America really at the end of the 19th century, the beginning of the 20th century. And so they're animals that, dinosaurs did look like that, but that's really just sort of a tiny part of the overall picture of dinosaurs. And we're now finding really strange dinosaurs. I mean, there was one discovered in China in 2015 that was about the size of a pigeon. It's an animal called Ichi, and it had these long rods of cartilage that came out from its hands, and it had very long fingers. And researchers realized that actually it had these membranes of skin. And so basically it was a dinosaur, a carnivorous dinosaur, that had evolved the bat method of flight. It was also covered in feathers, but it had these membrane wings, and it had these four long ribbon-like feathers that came from its tail as well. So it was really very strange. It's kind of animals that are breaking our stereotypes of what dinosaurs were. But there was also another dinosaur that was kind of properly understood from Mongolia about 3 or 4 years ago, an animal called Dinochirus. And I mean, this
That's
one...
weird.
It's
real
huge.
weird.
Yeah, it was a huge dinosaur. It would have been about 11 meters in length. It had an enormous hump like a camel, and it had these great long claws that would have been about 1 meter in length, and kind of a pot belly, and it had these strange feet with that were sort of wide and flat that may have helped it balance on soft mud or something.
And a head like a horse, kind of,
Yeah, but with a kind of long flat
Snout.
bill as well. Yeah. So, no, they're very strange animals.
Yeah, indeed. I mean, so there is... there's so much more to discover about new species, but there's so much more to discover about even the species that we have known about in the past. Because, I mean, just in the last week, I don't know if people saw, there was a news item about T-Rex and how they reckon that T-Rex wasn't the real fast runner that it used to be. Thought that it was, that actually it could only move maybe about 20 k's an hour, as fast as a fast jog, a human fast jog, because if it moved any faster, it's the bones in its leg. The bones in its leg would break, and so that's just an example, isn't it, of even things that we were pretty certain of. We're still revisiting and finding that maybe they weren't true, that maybe there was another, aspect of this creature or another reason, or because with T-Rex it was how maybe they didn't chase down their prey, maybe they had to sneak behind a tree and wait for it, or were scavengers, etc.
Well, it just sort of illustrates the point, actually, of how little we know. Even when you've discovered a species, you can learn so much more about it. And as you find more specimens as well, you're able to compare those specimens. And there are loads of great new digital models on computers now that allow us to reconstruct kind of the muscles and the tendons and the bones of dinosaurs and how they all work together, and how these animals might have actually been able to move, and the stresses and strains on the bones. But I mean, that question of T-Rex running is actually something that tends to go backwards and forwards, and this question of whether it was a scavenger that was an animal that maybe didn't move that fast, or whether it was a pursuit predator. People are often sort of finding contesting discoveries in that area. But I mean, T-Rex is an animal that engenders so much interest that there are many new, there was a study that came out last year kind of looking at the purpose of T-Rex's arms, and there was one that just came out a few months ago that was, for several years now we started to think probably adult T-Rexes were animals that were covered in feathers, but there was a study that came out a few months ago that had looked at a whole series of skin impressions from full-grown T-Rexes, suggesting that maybe they weren't animals that were covered in feathers as adults, but they could have been animals that were covered in feathers as juveniles. And equally, a juvenile tyrannosaur, they may have been very fast-running animals, whilst larger T-Rexes may have not, and they may have actually kind of had different niches. Maybe smaller T-Rexes were animals that were pursuit predators, and larger T-Rexes were animals that were largely scavengers.
Would it be overstating it to say that there are still thousands of dinosaur species that still haven't been discovered?
No, it wouldn't be overstating it at all. I mean, like I was saying, we've probably found, about 1,300 species of dinosaurs, something like that. But if you look at birds and mammals today, just birds alive, species of bird alive on the planet at this moment, about 10,000 species of birds. So birds are dinosaurs. But then if you imagine, most species only exist for kind of 2 or 3 million years before they go extinct. So there's kind of a great turnover of different species. And you think that dinosaurs, the larger dinosaurs as a group, were around for like 200 million years. So, there may have been 10,000 dinosaurs alive at any one point during that time, but there would have been huge turnover of species over that time as well. So it may be that, saying there were tens of thousands of species of dinosaurs, even that is an enormous underestimate. And what that says to us is that what we're seeing is just we have a tiny, tiny window into the overall picture of dinosaurs, and we're trying to understand everything based just on that very small amount we can see. But also excitingly, it means that we're going to continue to find huge numbers of dinosaurs. So currently there's a dinosaur discovered about every week. There's a new dinosaur species discovered, and there's a good chance in coming years that rate of discovery is going to increase, not plateau. The
reality is we're never going to discover all of them, because some of them might have died in environments where it's just not conducive to being fossilised. Is that correct?
Yeah, absolutely. Fossilisation is very unlikely anyway.
It's 1 in a billion, isn't it?
Yeah, I was trying to remember what the figure was. Bill Bryson in his book, A Short History of Everything, he has this figure, 1 in a billion bones is fossilised. So the chance of you being fossilised is very, very unlikely, but it's more likely if you live in certain environments. If you die around the shores of a river or a lake, and you're in the kind of environment where deposits are likely to build up on top of you, you're much more likely to be fossilised than if you live in a jungle where things rot very quickly, or if you die on top of a mountaintop. So we're probably never going to get the dinosaurs from many of those environments where you're unlikely to be fossilised.
One of the things, let's just finish with Jurassic Park, because now that we know that it wasn't true that T-Rex could chase down Jeff Goldblum as he's driving away in the Jeep, etc. And one of the things, obviously, that came up in Jurassic Park was bringing dinosaurs back to life again. And let's just let's just deal with that one, John. Is it possible that dinosaurs could ever be brought back to life?
Yes. I think I would say yes, but not through DNA.
Yeah.
Not through preserved DNA from fossils.
Yeah.
Yes.
First of all, explain why we can't bring dinosaurs back to life through DNA.
Yeah, so DNA has been found in fossils probably going back to about 1 million years now. But DNA is a very fragile molecule. It easily degrades. It doesn't last very long. So stuff that we have found perhaps going back to 1 million years is incredibly fragmentary. So, if you're talking about sort of useful, meaningful pieces of DNA, sequences of DNA, probably there isn't stuff older than like 100,000 years that you can do anything enormously useful with. So the larger dinosaurs died out 66 million years ago, so that just means we're very unlikely to find any useful sequences of DNA that you could use for cloning. And it's not really to do with technology, it's to do with how fragile DNA is.
And it's too degraded.
Yes.
Yeah. Mm-hmm.
But birds are dinosaurs. They're living dinosaurs, and so really within their DNA they have the majority of dinosaur DNA as well. And what tends to happen through evolution is that new traits evolve, but you may still carry the sort of genetic instructions for traits that your ancestors had, but that are no longer expressed. So it might be that many of the traits that dinosaurs had, for their jaws and teeth and their long tails and their claws and their size, might still be encoded somewhere within the genomes of birds if we're able to understand how we can actually do anything with this information. So there has been a project in the US over the last 5 years where a researcher called Jack Horner in Montana has been working with some guys in Canada, and they say that they're trying to developmentally back program a chicken. So basically, they want to. They're taking embryos of chickens and they're trying to find ways to turn on certain genes for particular traits. So to turn on the genes that might give a chicken a more reptilian jaw, or give it claws, or give it a long bony tail like a reptile. So you don't know where this kind of research is going to go in the future. It's kind of a curiosity at the moment, but you just don't know.
Are you a fan of trying to go too far down that path, though?
I don't think we're going to be able to stop it. If you can do interesting things, then I think people are going to try and do them. So, yeah. Okay,
if you could bring one dinosaur back to life, what would it be?
I think my favourites are these four-winged flying dinosaurs. Something with four wings is just so alien to anything that we have alive today. They're pretty cool animals.
Thank goodness you're not bringing Titanosaurus to steer through a 7th floor window at me. That's good. Look... a lot of these discoveries, like you say, are being made in China. Can you explain a bit about how these discoveries are being made and who's making these discoveries? A lot of them, as I understand, are by farmers, local farmers.
Yeah, so what's really happened since the 1990s, and part of the reason why there has been this enormous explosion in discovery all over the world, is that we're starting to look in parts of the world where we haven't really looked before for fossils. So, prior to the 1970s or something, a lot of dinosaur discoveries might have been from North America or from Europe. And they often weren't from developing countries. So people have started to look in earnest in the last 20 years for dinosaurs in developing countries. And also there are researchers from China, from Argentina, from Madagascar, who have gone to the West to study and learn under Western paleontologists, and they've now gone back to their home countries and they're building their own teams and capabilities. And there's also growing wealth and development in a lot of these developing countries that mean that there are teams of paleontologists, and in fact China probably has more money and more resources for paleontology than any other country in the world at the moment. But you're right in saying that a lot of the fossils there were found by amateurs. What started happening in the 1990s is that farmers in this it's a northeastern province of China called Liaoning. It's right on the border with North Korea, and that's really where a lot of these feathered discoveries have come from. It wasn't a very wealthy part of China, but people started to realise in the 1990s that there were some incredible early bird fossils that were coming out of the ground there, and some entrepreneurial farmers and subsistence farmers who lived there started to actually go and dig these fossils up for themselves and sell them to collectors and museums. And when people realised there was money in this, more and more people started looking for fossils. And really that's why we've had this kind of incredible tide of new discoveries in China, because there are so many people looking for them.
Has that led to a black market in these species?
Yeah, absolutely has. So, it's kind of, in some ways it's been a great thing because we've found so many new species and there are huge numbers of dinosaurs coming into collections. But at the same time, it also means that a lot of specimens are lost to the black market and to private collectors. And when amateurs collect fossils, often they don't collect any of the kind of contextual information. And unless you know precisely from which kind of geological layer the fossil is from, you can't really say anything precisely about the age of the animal. And you can also tell a lot about how the animal died and how it fossilized by looking kind of at the rocks and the conditions in which it was fossilized. So without that information, you sort of lose a lot of the scientific value of fossils. So yeah, it's been a good and a bad thing, really. But
there's huge money. A T-Rex fossil sold, called Sue. How lovely is that? Sold for $8.3 million US in 1997. partly unfortunately paid for by Disney World and McDonald's, it turns out. But I mean, that's the kind of money that some people might be willing to pay for good fossils. Is that correct?
Absolutely. And I mean, there's just incredible fossils coming out of China, Mongolia, Morocco, Egypt, Brazil, and there are private collectors who are willing to pay for some of these specimens. So there are some important dinosaurs that were poached, ended up on the black market, but then came to the attention of paleontologists, and they were able to be brought back to museum. I mean, one of them was this strange sort of humpbacked animal with the duck-like bill, Dinocaris from Mongolia. So researchers did some fossil digs in Mongolia in about 2012, and they found some strange remains of an animal, but the hands, the feet, the skull were all missing, and they knew that these specimens had been poached. I mean, I've seen this myself on fossil digs in Mongolia. You go to some of these sites, and there are little plastic balls of superglue like strewn all across the ground. And what the poachers do is they go into some of these sites, they dig things up really hastily. They'll just take this kind of small valuable stuff rather than the whole specimen, because they can extract it quickly and smuggle it out of the country. So with dinosaurs, that usually involves just the hands, the feet, the heads, and they put the superglue on them because they're trying to kind of set the fossil very quickly so that they can extract it without it falling apart. But so, I mean, yeah, there are a number of examples. There's Dinocaris, but there's also this massive aquatic dinosaur discovered in Egypt and Morocco, an animal called Spinosaurus. I mean, that was the really same cool thing. Too, yeah, it is, isn't it? Yeah.
Just dealing with that kind of people with bits of superglue and things, there's also been a little bit of a trade in fakes and forgeries, essentially. And some of these people are really good. And in one case, National Geographic, the magazine, got sucked in by a specimen, didn't it? Can you just tell us a little bit about that?
Yeah, so, I mean, National Geographic had a story in, I think it was 1999, on this new feathered dinosaur, an animal that they called Archaeoraptor. And it was kind of a bit of a controversy at the time, but shortly, months after it had been published in the magazine, it was shown that this animal had actually been a composite of a dinosaur and a bird that had kind of artfully been put together, and it had fooled the scientists. And, National Geographic had to sort of launch an investigation and had to have an embarrassing retraction. And but I think paleontologists in China have learnt a lot since then. I mean, this was when some of the first feathered dinosaurs were still being discovered, and in the same way that these farmers realised they could make money from discovering real dinosaurs, people started to realise you could make a lot of money from artfully creating fake dinosaurs, and often they were composites, or they'd kind of added flourishes and stuff to the fossils to improve them, to make them look like more interesting and valuable fossils. So yeah, it's certainly been a problem, but I think it's becoming a bit less of a problem in China because people are very aware of fakes now.
How competitive is it amongst paleontologists, to find fossils?
It's very competitive. Yeah, there are certainly a lot of big egos out there among paleontologists, and they're all racing to have the big discovery. Yeah,
but it's always been like this, and perhaps the story of discovering dinosaurs throughout the centuries is littered with characters and fantastic people that have been obsessed with this. I mean, one that stands out is a fabulous Transylvanian aristocrat who rode around on a motorbike called Franz Baron Nopschke. And can you tell us a bit about him? Which it's both a fantastic story and a really, really sad story.
Yeah, I mean, it's an incredible story. I mean, a lot of the scientists and they weren't really paleontologists then. They were just people who had an interest in natural history and science. But a lot of them in the late 19th century, early 20th century were aristocrats. So one of them was this Transylvanian Baron Franz Nopschke, and he found this whole series of strange dwarf dinosaurs in Transylvania. So he found sauropods, normally enormous, long-necked dinosaurs like the one that we were talking about that's kind of 40 metres in length, 70 tonnes. But he found this sauropod in Transylvania that was about the size of a cow or a horse. So it was very unusual. And then he found a series of other dinosaurs as well, also from Transylvania, that were much smaller than these species from other parts of the world. And they were able to tell that they were adult animals, not juveniles, because you can see a change in kind of how bones are fused together and the internal structure of the bones. So, and what he deduced at this time, he was very ahead of his time. He deduced that Transylvania or Romania had actually been an island. And we see something in the world today called island dwarfing, or you see an effect on islands where some animals grow very large compared to their kind of counterparts on the mainland. Other animals grow very small. So the same thing happened with mammoths on some sort of islands in Siberia, and I mean that's perhaps why moas were so huge in New Zealand as well, because of this strange effect that islands have. So this guy, Baron Nopcsa, was really ahead of his time, because he had this idea that it had been an island. He also theorised that birds had evolved from dinosaurs. He theorised plate tectonics, which nobody really believed at the time. So in lots of ways he was really ahead of his time, but I think really he is one of the most colourful characters in the history of paleontology. So yeah, he was a spy for various Balkan states in the years running up to the First World War, and he actually had his own bid to become the king of Albania in the years after the First World War as well, which didn't work out. But he was very troubled as well. He was also very unusual for his time in having sort of largely open relationship with another man, his lover, a guy called Bayezid Doda, who actually he called him his secretary, and he sort of actually was involved in a lot of his research too. But it had a very sad end to his life, because he killed himself and his lover in a double suicide in 1933 in Vienna. So he woke up one day, he gave his lover was an alcoholic at the time, he gave him sleeping tablets crushed into tea, and then he shot them both. So yeah, it's a very colourful story in history.
Colourful, but really, really sad, as you say. John, as well as writing about dinosaurs and dinosaur discoveries, you've done a lot of digging yourself, and you've led groups to dig in Mongolia, etc. Can you just give us an idea about what that entails? How on earth do you think, I'm going to go and find a dinosaur fossil, I'll just start digging here? I mean, what is Mongolia? China's a big place. Where do you start? How do you start?
So, the digs that I've been on have been, well, I was the editor of Australian Geographic magazine until a bit earlier this year. So over the last 3 years, we had run fossil digs with the Australian Opal Centre in Lightning Ridge in New South Wales, and then in 2015 and 2016 we'd also run dinosaur digs in collaboration with the Mongolian Academy of Sciences. And we would partner with these organisations really that were doing their own fossil dig work, but it was a way for us to offer these dig experiences to readers. So in Mongolia, you know where to go and look for dinosaurs. For a start, you look at the geology of a region. So really, you're looking for places where rocks of a certain age are exposed. So, if you want to find dinosaurs from 100 million years ago, which was some of the stuff that we were looking at in Mongolia, you look for places in the Gobi Desert where you know that rocks of 100 million years old are exposed. And then you also look for places where you're more likely to turn up fossils as well. So you're much more likely to turn up fossils in kind of upland areas where there's a lot of erosion, where water or wind is like slowly removing the layers of soil, and bones are more likely to be exposed. So these guys in Mongolia have very intimate and detailed knowledge of all of the dinosaur-bearing parts of their country and the ages of these places. And so in fact the places that we've been to in Mongolia over the last couple of years are places that they've been going to repeatedly for 20, 30 years now. And in Mongolia, in the Gobi Desert, the winds and the sandstorms are so harsh every year that they kind of scour off a new layer of the surface. So when you go, you find stuff there. They were basically saying if we don't collect these things now, by next year they'll be destroyed, they'll be gone. So, and some of these sites you're just tripping over fossil bones as well. So where we went 2 years ago, we went to one site where there were the remains of lots of duck-billed hadrosaurs, and there were fabulous bones that the researchers just stepped over, and we just left them behind because they already have 50, 100 specimens of this species in their collection, and they didn't want any more. So they just have an embarrassment of fossil riches in Mongolia.
I read a wonderful quote that you had from one paleontologist telling other people how to find fossils, and this was in Antarctica, who said, keep your eyes down and look for weird things in the rock. And I guess, that's a good rule of thumb. But just mentioning that, Antarctica, there were polar dinosaurs, and we're finding fossils of dinosaurs in Antarctica at 4,000 metres. Way higher than about the height of Mount Cook, in the most extraordinary and extreme environments. Can you just explain how that's happened? Because Antarctica wasn't quite the same then as it is now.
No, that example from Antarctica just really has to be the harshest conditions anyone has ever collected fossils in anywhere in the world. You know, it's sort of very near to the South Pole there, and at 4,000 meters. And this group of researchers was up this mountain with a jackhammer digging out dinosaur fossils, you know, and they've got they're getting altitude sickness as well. They've got pounding headaches because of the low oxygen levels, and over a period of about 10 years, they managed to go back about 3 or 4 times, and they found the remains of at least 2 species of dinosaur from this site up on the mountain there. And so there's a carnivorous dinosaur called Cryolophosaurus, and a sauropod called Glacialosaurus, but actually those animals lived in quite a warm world, and that part of Antarctica at that time was not exactly in the Antarctic Circle. So they were not really dinosaurs that lived in a polar environment necessarily, but we do have a lot of evidence of a lot of dinosaurs that were living in polar environments. And in fact, there is some evidence of dinosaurs from New Zealand, and during the Cretaceous period, New Zealand was attached to the other southern continents to form the southern supercontinent of Gondwana. So, you know, that was Australia, Antarctica, South America, Africa, the Arabian Peninsula, India were all joined as one supercontinent, and parts of New Zealand were part of Gondwana as well. So New Zealand and southern Australia were part of Gondwana that in the mid to late Cretaceous would have been within the Antarctic Circle. So the whole world was a lot warmer at that point. So it wouldn't have been cold as it was. There were probably no ice sheets, but it would have been cold, and it would have got down to 0 in Antarctica and the Arctic during winter. And of course there would have been 3 months or more of complete darkness as well. So, and there have been fragmentary remains of a whole series of dinosaurs found in New Zealand. I'm sure some of you guys know about a lady called Joan Whiffen, who she was an amateur paleontologist, and she found a series of bones over about 20 years in a river valley on the east of the North Island, and she found she found a backbone of a titanosaur dinosaur, similar to that enormous titanosaur that we were
Patagonia,
talking. Yeah. So, but these dinosaurs, they're only very fragmentary remains from New Zealand, so none of them have been able to be described as a species, but they show us that there were, 4 or 5 different kinds of dinosaur that we know were here, and that these would have been polar dinosaurs, so they would have lived in these dark, cold environments. And we have a lot of evidence, actually much more evidence from Alaska, of dinosaurs that would have lived well within the Arctic Circle. And they were animals that were living in the Arctic Circle year round, so there had been an idea initially that they might have been animals that just sort of migrated there in the summer and then migrated further south in America. I mean, at that time it was Laurasia, but they might have migrated south in the winter, but we've started to find evidence of eggs and baby dinosaurs in what would have been the very high Arctic during the Cretaceous. So it shows us these animals were living in these cold environments year round, so they must have been animals that were cold adapted. And we have evidence of a small carnivorous dinosaur from Australia, an animal called Lialinosaura, that's from Victoria, and it had huge eyes. So it might be that, you know, having enormous eyes was one of these adaptations to sort of living in months of darkness. But they were probably also, the carnivores were almost certainly covered in shaggy coverings of feathers, so they might have been a bit like woolly mammoths or woolly rhinos. You have woolly dinosaurs as well.
Is your hunch that we will find more evidence of dinosaurs in New Zealand?
I think there's every chance, because what Joan Whiffen found was sort of small fragments in the river valleys, but as far as I know, there's never really been sort of large-scale paleontological expeditions launched in New Zealand, so I think it's very possible.
Yeah. Hey, look, as we've mentioned that there's so many new things that we're learning about dinosaurs, one of the things that's fascinated me is we know what colours they were now and what the feathers were. Can you just briefly explain how on earth we know that from a bit of a rock, a fossil, from a fossil?
Yeah, I mean, there have been a bunch of things about dinosaurs that we've discovered in the last 5 or 10 years that nobody could have ever predicted we would have known anything about before that point. And, and colour was one of those things that people were just absolutely sure that we would never know anything about. But these fossils from China, with the feathers are often preserved in such incredible detail that you can look at them under a scanning electron microscope and you can see the fine structural surface detail of the feathers as it would have been in life. So in mammals and birds, in humans, hair and feathers and fur is coloured by a pigment called melanin that comes in a sort of range of shades. It's stored in these little tiny packets called melanosomes. So for some reason, the shape of the melanosomes correlates to the colours. It's just coincidental, but they correlate. So oblong melanosomes might reflect kind of orange or brown colours, but round melanosomes might. I'm not sure exactly which way it is round, but round melanosomes might reflect black colours. You can actually see these melanosomes under the scanning electron microscope on the fossils. So researchers have been able to take the feathers of living birds, look at the shape of the melanosomes, correlate them to colours, and then look at the shape of the melanosomes on the fossils, and then so we now know. Well, we have very good guesses of the colours for probably around 8 different feathered dinosaurs, and they show that some of them were animals that had black and white stripes. They might have had colour a bit like magpie, or Archaeopteryx had sort of dappled black, white, grey colouring, and it also had some iridescent sheen as well that they've been able to tell from the fossils. But there are other dinosaurs. The first feathered dinosaur that was discovered in 1996 and showed this little animal called Sinosauropteryx. It was about 1.5 meters long. It had a kind of fluffy orange fur, and it actually had white stripes down its tail, a bit like a ring-tailed lemur. So it's just pretty incredible that we've been able to discover these things.
And another thing that we've discovered is that dinosaurs didn't have vocal cords. So here am I thinking that dinosaurs roared and were really scary, but actually they probably made sounds, more bird-like sounds.
Yeah,
is
we're
that
just
right?
not sure. So mammals have a larynx. Birds have a slightly different setup. They have something called a syrinx. So that mammals tend to be able to make these kind of throaty growls and roars, and certainly in the Jurassic Park films, that's sort of how dinosaurs have been. T-Rex was depicted, but the kind of sounds that the range of sounds that birds make is a little bit different, and it might be that we can get a better approximation of what dinosaurs sounded like by slowing bird sounds down and also making them much deeper as well to kind of reflect the much larger size of the large carnivorous dinosaurs. So that might give us a sort of better approximation of what dinosaurs sounded like. But there was actually in about a year ago, on one of the Antarctic islands, there was a fossil of a duck or a goose, and it was discovered, and it still had its syrinx and all of its voice apparatus there in the fossil. So, and that was a dinosaur era bird. So there is a very good chance that we might find some surprising bits of soft tissue and start being able to learn something about the actual sounds that dinosaurs make. There is also one dinosaur, that an animal called Parasaurolophus, that has a kind of a huge head crest that's hollow inside the fossils. And so about 15 years ago, researchers actually sort of fitted it with a wind instrument mouthpiece, and they were able to make these very strange sounds through this head crest, and they think that Parasaurolophus might have been an animal that used this head crest a bit like a trumpet to make sounds.
Have you heard what it sounds like? Can you do an impersonation?
I can't do an impersonation. I have got the recording. Yeah, maybe I can play it tomorrow.
Okay. Hey, we've got a few moments for questions. If people have got questions from John. Catherine.
Hi, John.
Hi.
Can you tell us how the ownership of a discovered fossil works? Is the person who stumbles over it the owner, or is there legislation around that to protect these discovered?
Yeah, it's completely different in different countries and different parts of the world. So in Australia, if you find a fossil on your land, then you do own that fossil, but there are strict rules about exporting fossils from Australia. But in other countries, in Mongolia, you're not allowed to collect any fossils at all. All fossils are property of the state, and it's very difficult to get a permit to collect fossils, because in Mongolia they had this real problem with poaching. So, but then in the US, there's a real complex patchwork of laws between different states as well, and there have been lots of court cases about fossil discovery. So yeah, it really varies in different places. In the UK, you can just go and collect fossils and I do that actually on the Jurassic Coast in Dorset and Devon in the southwest of England. If you find fossils there, they're yours to keep. Yeah.
Other questions,
Why did
madam?
they take the dinosaur out of the Natural History Museum?
That's a good question. Yeah, this is. I'm surprised that they did that as well. They've removed Dippy, and currently it's on a tour all around museums in the UK, and they've put an enormous skeleton of a blue whale into that entrance hall instead. But what they're eventually planning to do is bring Dippy back and just put it into another hall, so it will be somewhere displayed in the museum. It just won't be in that main entrance hall. And I think the feeling was that they just wanted it to sort of better reflect modern problems with biodiversity and conservation in our living world today. But I personally think it was a mistake. Yeah.
Naomi.
I was wondering why we haven't had many archaeological digs in New Zealand and how we might get some.
Yeah. I don't know a great deal about it, to be honest. But I mean, as far as I know, there are no working dinosaur scientists in New Zealand, so there's probably just not sort of capacity here. And because the remains are so fragmentary, there's probably not been that much interest from people overseas to sort of mount an expedition here if there's a chance they might not find anything. But I'm not sure. Yeah.
John, come back and find dinosaurs in New Zealand.
I'd love
please.
to.
Yeah, please do.
Somebody wants to pay me to mount an expedition.
Well, this is the thing. You lead expeditions where people they pay you to come along and
with Australian Geographic, really I've hosted fossil digs, but we're always working in collaboration with scientists. So we run this. We've run this fossil dig in Mongolia 3 years in a row, but with Australian Geographic, we had also worked with the Australian Opal Centre in Lightning Ridge. But really, the readers of the magazine were coming along as volunteers to help with the fossil collecting, but these expeditions were always led by the scientists. Yeah. And in fact, Joanna over there has last year she came on our.
Joanna, you're responsible for getting John here.
Yes.
First place. Thank you so much, Joanna. We owe you. Yeah.
So Joanna came out to Lightning Ridge last year and found some stuff as well, didn't you?
Yeah, it was great. The bird fossil. You could mention about the opalized fossilised.
Oh, I didn't. Sorry, I ran out of time. I had that there. That is a great story too. All right, have we got just a couple more minutes? Yep. Just tell us about. What's been found at Lightning Ridge?
So Lightning Ridge in Outback, New South Wales is an opal mining town, and opal miners there, for many decades, have been starting to find small fossils, and really now they've started to find a lot of dinosaur material there. But the really unusual thing about the fossils there is that they're preserved as opal, and sometimes incredible gem quality opals as well. So there are many dinosaur teeth and claws and other bits of dinosaurs that are pure opal. So it's just a very unusual location. If anyone's coming tomorrow, I've got some great slides with images of these opalized fossils, but they're pretty mind-blowing. It also means, sadly, that often the fossils are broken up into gems because they're so valuable.
As gems.
Yeah.
All right, I've got one last question. Very important, John. Do you still wear dinosaur pajamas?
Oh, damn it. But, I get asked this question by nearly everyone. I kind of wish I'd never put it in the book. I do have some dinosaur pajamas.
And show us your socks.
Especially today I wore my dinosaur socks. So yeah, they're like T-Rex on these ones.
They're pretty cool. Oh, look, John, thank you for being with us. John's books, as I say, Flying Dinosaurs, Weird Dinosaurs, they are full of fantastic stories of fantastic creatures and the amazing people that have hunted for them over the centuries. I really recommend them to you. John will be available after this to sign his books down the back. But in the meantime, can I just ask you to join me in thanking John for being with us today?